Hello students, in this video I will solve some problems in the miscellaneous exercise on chapter 2. See the first question. The question is like this. The relation f is defined by f of x is equal to x square, where 0 less than or equal to x less than or equal to 3, and 3x when 3 less than or equal to x less than or equal to 10. Show that f is a function. And we already studied this. This is a f of x equal to x square is a function in the set of real numbers. As 0 comma 3 is a subset of real number, this is a function. And similarly 3x is also a function. Here it is easy to tell that f is a function in between 0 to 3. Here I deleted 3 because f of x is defined as x square as well as 3x at x equal to 3. You can observe that at x equal to 3 it is x square as well as 3x. That's why I removed 3 and let us check for 3 later. And similarly f is a function in between 3 to 10. Here also 3 is removed, and in between 3 to 10 it is a function because it is a 3x. And what about at x equal to 3? Just check here. And f of 3 is equal to 3 square is equal to 9, and f of 3 is equal to 3 into 3 is equal to 9. At x equal to 3, even it is defined in different way, and the image is same here. F of 3 is equal to 3 square is equal to 9, and f of 3 is equal to 3 into 3 is equal to 9, and therefore even it is defined in different way, the values are same. Therefore f is a function in 0 to 10. The relation g is defined by g of x equal to x square, where 0 less than or equal to x less than or equal to 2, and 3x when 2 less than or equal to x less than or equal to 10. And to show it is not a function, it is sufficient if we check at the point 2. That's why I directly check at the point x equal to 2. What is the value of g of 2? When it is defined as x square, it is 2 square is equal to 4. When it is defined as, if you take g of x equal to 3x, then g of 2 is equal to 3 into 2 is equal to 6. And we can see that 2 is having different image, therefore g is not a function. Now you take this question. If f of x equal to x square, find f of 1.1 minus f of 1 divided by 1.1 minus 1. And to see this, let us find f of 1.1 first. And what is f of 1.1? 1.1 whole square. What is 1.1 whole square? 11 square is 121. Therefore, it is 1.21. And what is f of 1? F of 1 is equal to 1 square. 1 square is equal to 1. And substitute these values in the expression. F of 1.1 minus f of 1 divided by 1.1 minus 1. That is 1.21 minus 1 divided by 0.1. That is 0.21 divided by 0.1. That is equal to 2.1. Take the next question. Find the domain and range of the real function defined by f of x equal to root of x minus 1. And here we have already solved similar question in the earlier exercise. We have to find the domain and range of the real function. Here root of a something is defined when that something should be greater than equal to 0. That is x minus 1 should be greater than equal to 0. X minus 1 is greater than equal to 0, same as x is greater than equal to 1. And you can write it in an interval, that is greater than equal to 1 means 1 to infinity. And that is the domain is 1 to infinity. Here 1 is included. That's why you should represent it by a square bracket 1 comma infinity, and this is the domain of the function. What is the range of the function? Here range means what are the values taken by f of x, and f of x may be any positive real number including 0. When it is 1, when x equal to 1, you can observe f of x equal to 0. That's why the range is x is greater than equal to 0, or you can write it as 0 to infinity. Here 0 is included, and this is the range of the function. And the next one is find the domain and range of the real function f of x equal to mod x minus 1. Here mod x minus 1 is defined for every real number. That's why the domain is the set of real number. And what are the values taken by mod x minus 1? Mod x minus 1 is always greater than or equal to 0. Therefore, the range is x is greater than or equal to 0, where x is a real number, or you can write in interval, it is 0 to infinity. And this is the range of this function. Next one, let f is equal to x comma x square divided by 1 plus x square, where x is a real number. Be a function from R to R, determine the range of f. Here you have to observe carefully. Range means you have to understand what are the values taken by y, where y is equal to x square divided by 1 plus x square. And just let us analyze like this. And you know that x square is greater than or equal to 0, because square of any number, real number, is always positive. X square is greater than or equal to 0. And also 1 plus x square is also greater than or equal to 0. As both numerator and denominators are greater than or equal to 0, you can tell that x square divided by 1 plus x square is also greater than or equal to 0. And hence the values taken by x square divided by 1 plus x square is always greater than or equal to 0. And this you have to note it. Next, let us analyze what is the maximum value taken by x square divided by 1 plus x square. Just let us analyze like this. And you know that 1 plus x square is greater than x square, because for x square 1 is added. Definitely it is greater than x square. And that's why if you divide throughout by 1 plus x square, 1 plus x square is a positive number. If you divide it by a positive number, then equality will be same thing. It is 1 is greater than or equal to x square divided by 1 plus x square. And this shows that x square divided by 1 plus x square is always less than 1. It cannot be more than 1. Just you can observe here. X square is always smaller than 1 plus x square. That's why x square divided by 1 plus x square, when the numerator is smaller than the denominator, definitely it is less than 1. So x square divided by 1 plus x square is always less than 1. And it is greater than or equal to 0, you know that. That's why. And what is the range of the function? It is 0 to 1. Here 0 is included. Now you take this question. F is equal to 1, 1, 2, 3, 0, minus 1, minus 1, minus 3. Be a function from z to z defined by f of x equal to ax plus b for some integers a and b. Determine a and b. This is an important question, very simple question. And here 1 comma 1 is in f, means f of 1 equal to 1, f of 2 is equal to 3, f of 0 equal to minus 1, f of minus 1 equal to minus 3. That is the meaning of this. And it is given that f of x equal to ax plus b. Therefore, f of 1 is equal to 1. If you put x equal to 1, we will have a into 1 plus b is equal to 1. We call this equation 1. And we can use the second equation. Instead of that, I will take the third result, f of 0 equal to minus 1, because you can calculate the values easily. And what is f of 0? F of 0 equal to minus 1. A into 0, 0 plus b is equal to minus 1. And hence you will get the value of b directly. What is the value of b? B is equal to minus 1. Substituting the value of b in equation 1, and you will have a plus minus 1 equal to 1, or a is equal to 1 plus 1. And what is the value of a? A is equal to 2. And this is the method of finding the value of a and b. This is one of the important question. Next question is, let R be a relation from n to n defined by R equal to a comma b, where a and b belongs to n, and a equal to b square. Are the following true? First question is, a belongs to R for all a belongs to n. Second one is, ab belongs to R implies ba also belongs to R. Third one is, AB belongs to R and BC belongs to R implies AC belongs to R. And to analyze this, you have to think in general, but here this question is simple, because it is sufficient if you give an example. Now, to solve this problem, let us take some example and let us check whether the particular element is in R or not. Just I will write one element. 2 comma 3. Whether 2 comma 3 is in R, you have to check whether this element is in R or not. And how to check it? And you have to check whether this condition is satisfied. A, what is A here? 2. What is B? 3. Whether 2 is equal to 3 square? No, 2 is not equal to 3 square. Therefore, this element is not in R. I'll write one more element. See here. 2 comma 4. Whether 2 comma 4 is in R? No, 2 comma 4 is also not in R because 2 is not equal to 4 square, right? And I will check one more element. Whether 9 comma 3 is in R. Just check here whether 9 comma 3 is in R. Whether A, 9 is equal to 3 square. Yes, therefore 9 comma 3 is in R. And this is the way of verifying whether the given element is in R or not. Here the first result is A comma A belongs to R for all A belongs to N. Whether 2 comma 2 is in R, 2 comma 2 is not in R because 2 is not equal to 2 square. Therefore, this result is false, right? And this is not true. The reason is 2 comma 2 is not belongs to R. Similarly, you can give 3 comma 3 also not belongs to R. 4 comma 4 is also not in R. But only 1 comma 1 is there. Just check here. 1 comma 1 is in R because 1 equal to 1 square, right? And that's why here it is given that for all n belongs to n. That's why here 2 comma 2 is not in R. Similarly, you can check whether the second result holds. And just here, A comma B belongs to R, whether B comma A belongs to R. And you can give this example and analyze. You can see here, and it is also not true. The reason is 9 comma 3 belongs to R, right? 9 equal to 3 square. Whether 3 comma 9 belongs to R? No, because 3 is not equal to 9 square and 3 comma 9 not belongs to R. Here this result is false. AB belongs to R implies BA belongs to R is false statement. And third one is this is also not true. A comma B belongs to R, B comma C belongs to R implies A comma C belongs to R. Here you have to choose a proper example to give justification. And here we have to choose two elements that A comma B belongs to R and B comma C belongs to R. And see here 16 comma 4 belongs to R because 16 equal to 4 square, and 4 comma 2 belongs to R because 4 equal to 2 square. But 16 comma 2 not belongs to R. 16 is not equal to 2 square. Here A comma B belongs to R, B comma C belongs to R implies A comma C belongs to R is also not true. With this much I will conclude with this video and continue with the other part in the next video. Thank you.